The James Webb Space Telescope is the biggest, most complex telescope that NASA has ever launched into space.
The discovery of a new exoplanet has astronomers excited that it could be, indeed, signs of life.
Unlike any other telescope we have ever had, the James Webb Space Telescope shows off just how much it is capable of. As it explores the cosmos, it brings to light things that we never knew existed. Its most recent discovery has been a shock to the whole world. It spotted signs of life in a parallel universe, way outside our solar system. Now you might be wondering, do parallel universes really exist? Is there life in the just-discovered universe? Join us as we delve into how scientists finally discovered a parallel universe. Signs of life on K2-18b. K2-18b, also named EPIC 2119-12552b, is an exoplanet orbiting a small red star named K2-18, positioned about 124 light-years away from us. Initially spotted using the Kepler Space Telescope, this planet is about 8 times more massive than Earth, earning it the nickname Mini-Neptune. It completes one orbit around its star in approximately 33 days, falling within the habitable zone where conditions may support liquid water. This zone receives a comparable amount of starlight to Earth from the Sun, raising the possibility of conditions similar to ours. What makes K2-18b intriguing isn't just its size and classification as a Hycean world, suggesting a unique atmospheric composition with hydrogen playing a crucial role in placing it within the habitable zone. This discovery sparks excitement because the James Webb Space Telescope might detect even small signs of life on K2-18b, expanding our understanding of distant celestial bodies beyond what was previously thought to be the edge of space. But that's not all. When the James Webb Space Telescope examined the distant K2-18b, a groundbreaking discovery reverberated through the scientific community. In addition to the anticipated carbon dioxide and methane in the alien atmosphere, an unexpected find surfaced: dimethyl sulfide, a molecule associated with Earth's life. On our home planet, dimethyl sulfide is produced by tiny sea plants, akin to a hidden code of life. This revelation positions dimethyl sulfide as a potential indicator of life, a phenomenon never previously encountered on an exoplanet. While scientists used to focus on signs of life on rocky planets, they are now turning their attention to Hycean worlds like K2-18b, which offer ideal conditions for studying atmospheres. This challenges the notion that only Earth-like planets can support life. In a universe filled with diversity, we are drawing closer to the prospect of discovering life beyond our familiar planet. However, our exploration of K2-18b is just beginning. Scientists, armed with initial data from the James Webb Space Telescope, eagerly await more information. Validating the presence of dimethyl sulfide and the potential for extraterrestrial life on this distant planet requires additional data and extended observations. Detecting signs of life is a complex task. While we recognize them on Earth, deciphering signals from space is challenging. The complexity increases because clear signs, such as oxygen, may originate from different sources. On Earth, oxygen is produced by plants and sea plants, but in other locations, it could arise from non-living sources. The scientific journey began with the search for planets resembling Earth and evolved to explore potential water-harboring regions. Now we are delving into the chemical compositions of planets beyond our solar system. Thanks to technological advancements, especially in atmospheric studies, we can identify signs that may indicate life on distant planets. Scientists are improving their ability to identify signs of life on planets outside our solar system. It's akin to discovering a special cosmic clue that could aid our understanding of the potential existence of aliens. All these exciting developments suggest that we are on the verge of unraveling the space mystery of life beyond Earth. And the thrill doesn't end here. Earth from space. The James Webb Space Telescope commenced its journey in 2021, embarking on an incredible adventure through space while uncovering some of the universe's most significant mysteries. Rather than solely focusing on the vast expanse of the cosmos, This telescope directs its attention to our cosmic neighborhood. Its crucial mission involves unraveling the ancient origins of the universe. In a recent bold move, scientists conducted a space experiment to test the James Webb Space Telescope's capability to detect signs of intelligence from distant locations. Can you guess the subject of this test? It was none other than our own Earth. Armed with extensive information about Earth's atmosphere, these researchers meticulously adjusted the data, causing the telescope to observe our planet as if it were a distant star many light years away. However, there's a challenge when observing Earth using the Webb telescope. Earth emits a lot of infrared energy because it's relatively warm, and the telescope is designed to detect this. If the telescope were to point directly at Earth from just 1,000,000 miles away, the strong infrared brightness could overwhelm its detectors, possibly causing damage. Adding to the problem is the telescope's orbit, which means that trying to observe Earth would also involve looking directly at the Sun, leading to the telescope's destruction. Nonetheless, the primary goal of the Webb telescope is not to study Earth. Instead, it is focused on examining more distant planets within our solar system and exoplanets orbiting other stars. Some of these exoplanets might share similarities with Earth in terms of their characteristics. The telescope's sensors were sent deep into space on a mission to search for signs of life, indicators that living things might exist. The focus was on substances like methane and oxygen, resembling space footprints that could suggest life, similar to what we have on Earth. The exploration didn't stop there. It extended to investigating advanced civilizations. The James Webb Space Telescope achieved remarkable results when observing Earth from the TRAPPIST-1 star system, located quite far away at 40 light-years. It specifically looked at substances like nitrogen dioxide and chlorofluorocarbons, which could be akin to signs left by intelligent beings in space. This examination has the potential to broaden its perspective, unveiling the mysteries of extraterrestrial civilizations up to 50 light-years from our home. Earth's ancient palette of purple bacteria. Scientists studied Earth's ancient history by looking at the Archean era, a time filled with various life forms, including the mysterious purple bacteria. During this distant period with early organisms, researchers conducted a curious study to understand how Earth's appearance might have been influenced by the widespread presence of these early life forms when viewed from a distance. To unravel this space mystery, scientists created different models and simulations that considered various factors. The focus was on the abundance and distribution of purple bacteria, which thrived in both water and on land. Additionally, the study took into account sky conditions, considering the presence and thickness of clouds during the studied times. The results of this space exploration were quite thrilling. It turns out that purple bacteria have a unique ability to reflect light interestingly. To grasp this, think about the well-known red edge effect observed in Earth's plants, where green plants appear more vibrant in the part of the light spectrum not visible to us. Similarly, purple bacteria exhibit their version of this uniqueness, showcasing special qualities in a slightly different range of colors. This distinctive interaction with light is due to their special pigments and how they absorb light to obtain the energy they need. This discovery extends beyond Earth's narrative. Consider this scenario. If a distant planet's land areas are rich in purple bacteria and its skies are relatively clear, upcoming telescopes equipped with special filters might be able to detect these tiny microbial experts. The James Webb Space Telescope, with its space maneuvers, plays a crucial role in these revelations, demonstrating its ability to unveil the secrets of the vast cosmic landscape. However, that's not the end of the story. Dark matter and energy. The universe's story is a bit confusing and full of debates, with various speculations, models, and recent surprising discoveries. Long ago, scientists believed that as time passed, things in space would gradually slow down due to gravity. But, surprise, the cosmic story took an unexpected turn, revealing that the universe is speeding up in its growth. This twist adds a layer of mystery, urging us to explore further and understand what's happening. In this vast universe, there's an intriguing duo known as dark matter and dark energy. Dark matter, like a subtle force spread throughout space, coordinates the cosmic performance by invisibly holding galaxies and clusters together. Making up 27% of the cosmic puzzle, it silently constructs the hidden framework that maintains celestial harmony. Although invisible to the naked eye, scientists can follow its gravitational clues to uncover its role. Astrophysicist Paul M. Sutter explains that the term dark universe is commonly used to describe our cosmos because, surprisingly, most of it is dark. Another mysterious force, dark energy, claims a massive 68% of the cosmic stage, causing the universe to expand faster. While unseen directly, its impact becomes evident through the careful study of how galaxies move. Astrophysicist Hakeem Olusei explains that, in a sense, dark matter and dark energy kind of work against each other. Despite its complexity, dark energy leaves an impression on the cosmic stage through precise measurements, such as background radiation and the overall structure of the universe. Another scientist calls it the dark force, as we can't say if it is made of matter. It could be a profound misnomer, sending people off in thought directions that might not be the right path. So, dark matter is simply what we call this thing about which we know nothing, responsible for 85% of the gravity of the cosmos. He describes it as the longest-standing unsolved problem in modern astrophysics. For a while, dark matter and dark energy were like interesting rumors in the vastness of space, but now, there might be a shift in how we perceive the cosmic picture. Stars, including our radiant sun, usually derive their energy from the core through nuclear fusion. A female scientist explains it this way. She says the specific nuclear reaction that powers the sun is fusion. A fusion of hydrogen into helium. You take two hydrogen atoms and ram them together, and what is left over is a helium atom. She explains further that it is hard to get two atoms to fuse. Two protons at the same charge that will positively charge will typically repel each other. This process blends lighter elements like hydrogen into heavier ones, mainly helium, creating the fundamental elements of stars and the radiant energy that illuminates the cosmos. However, there's now a hint at a different source of stellar energy: dark matter. In an interesting turn, the self-destruction of dark matter could release a significant amount of heat, possibly fueling the brightness of stars. This concept introduces a new perspective on how stars operate, suggesting that cosmic harmony might arise not just from nuclear fusion, but also from the mysterious energy hidden within dark matter's grasp. With what we have seen so far, what new thing will the James Webb Space Telescope look closely into the depths of the universe with its lens? Dark stars unveiled. The James Webb Space Telescope keeps making amazing finds with its lens wide open, missing no detail, capturing distant snapshots of celestial history. During this advanced survey outside the Milky Way galaxy, 4 stars have been found and named mysteriously: JD's GS Z10, JD's GS Z11, JD's GS Z12, and JD's GS Z13. Among these stellar wonders, JD's GS Z12 and JD's GS Z13 are standout celestial giants, residing among the most distant cosmic bodies ever captured in our telescopic view. JD's GS Z13-0 was found on September 29, 2022, using a special camera called NIRCam. In October 2022, another tool on the James Webb Space Telescope called NIRSpec double-checked and said, "The galaxy's redshift is Z13.2 with great accuracy." This makes it the oldest and farthest galaxy we know of with confirmed details as of 2023. The light from this galaxy took 13.4 billion years to travel to us. This galaxy is in the Fornax constellation in the area called Great Observatory's Origins Deep Survey, South Goods S, right where the Hubble Ultra Deep Field is. JADE's GS Z13-0 is now about 33.6 billion light-years away because the universe is getting bigger. However, these celestial bodies aren't your typical stars. In the intriguing realm of astrophysics, they are known as dark stars according to theory, and they don't follow the expected script. There's a possibility that their energy source is dark matter. A dark star is a theoretical category of celestial object that could have existed in the early stages of the universe, predating the formation of conventional stars. These hypothetical dark stars would mainly be made of normal matter, like today's stars. However, a large amount of neutralino dark matter inside them would create heat through annihilation reactions among dark matter particles. This heat would stop these stars from collapsing into the small and dense sizes of modern stars, preventing nuclear fusion among the normal matter atoms. Dark stars, veiled in the shadows of space, shine brightly, potentially exceeding the sun's brightness by 1 billion times and surpassing their stellar counterparts by millions of times in mass. The origin of these dark stars adds to the astrophysical mystery. According to the theory, they might have emerged shortly after the grand performance of the Big Bang, in regions filled with dark matter formed by the gravitational collapse of clouds containing helium and hydrogen, ranging from 1 to 960 astronomical units in size. Now, let's consider the concept of supersymmetry, a theory suggesting that dark matter particles have companions known as superpartners. In the early universe's celestial kitchen, these dark stars start their cosmic journey when clouds of helium and hydrogen, remnants from the ancient explosion, come together. The mechanics of the universe become fascinating. When dark matter particles have supersymmetry, they interact with their superpartners in space. This interaction leads to collisions, creating an energy burst similar to what happens during the interaction of matter and antimatter. This energy release results in the formation of new particles such as photons, electron-positron pairs, and mysterious neutrinos. While neutrinos, these elusive cosmic entities, manage to escape, the other particles remain, sharing their energy with hydrogen and helium in the cloud. This energy exchange becomes like the spark that ignites the engine, warming up the cloud and setting the stage for the birth of dark stars. Unlike stars powered by nuclear fusion, these dark stars emit less intense light, allowing them to remain cool for extended periods and grow to gigantic sizes. In this process, dark stars may reach temperatures comparable to the surface of our sun, but radiate with a brilliance that can rival entire galaxies filled with regular stars. If, by some chance, dark stars still existed today, we could potentially detect them by looking for emissions of gamma rays, neutrinos, and antimatter. These celestial objects would likely be linked with clouds of cold molecular hydrogen gas, which wouldn't usually have such energetic, extreme, and rare particles. Mini-halos. The Big Bang Theory stands as the most widely accepted explanation for the origin of our universe. According to this theory, everything we are familiar with originated from an exceedingly hot and dense singular point. From this point, there was a rapid expansion, stretching out at incredible speeds initially and then continuing at a more consistent rate. This cosmic unfolding occurred over a vast expanse of time, 13.7 billion years, resulting in the expansive and continually evolving cosmos we witness today. But there's more to the story of the Big Bang that might surprise you. About 200 million years after the Big Bang, something extraordinary happened, a cosmic event featuring small galaxies known as mini-halos. These cosmic nurseries were mainly made up of dark matter and appeared in the early universe when the key ingredients were simple: helium and hydrogen. The James Webb Space Telescope has been instrumental in studying the afterglow of the Big Bang called the cosmic microwave background. By working with other observatories, the James Webb Space Telescope gives us information about the early universe and how it started. In this early cosmic stage, the unique conditions within these mini-halos set the stage for the emergence of dark stars, a phenomenon hidden until advanced telescopes were developed. In the early universe, before heavy elements existed, the conditions were perfect for the birth of dark stars within these mini-halos. This remarkable cosmic performance remained hidden for a long time because our technological capabilities weren't advancing quickly enough to uncover the depths of history. The revelation of this secret awaited the arrival of a cosmic guardian, the James Webb Space Telescope. Acting like a time machine, the telescope enables scientists to peer far back in time. When it discovered dark stars in these small halos in space, it revolutionized our understanding of the universe. But how did the telescope uncover this cosmic mystery? Picture gravitational lensing as a cosmic ballet. Visualize a massive galaxy gracefully passing in front of a distant star or galaxy. The gravity of this galaxy bends the path of light, creating a celestial spectacle known as gravitational lensing. This performance doesn't change the actual distance of these objects, but it distorts and magnifies the light emanating from them. The result is a telescope show where distant entities appear larger or closer than they are. The vast distances in this cosmic dance made it challenging to identify these objects. Initially thought to be galaxies, careful examination and time-consuming computer tests indicated that 3 out of the 4 might be these mysterious dark stars. If this idea holds, the discovery of dark stars in these compact spaces could potentially solve 3 significant puzzles. Firstly, it could explain why the James Webb Space Technology observed numerous large galaxies in the early universe, contrary to previous assumptions. Secondly, dark stars might provide insights into the origin of massive black holes from the early universe, ones too massive to be born from regular stars. Lastly, the existence of dark stars could confirm the reality of dark matter particles and offer a glimpse into how they interact beyond gravitational forces. Mothra and Godzilla. The James Webb Space Telescope has discovered galaxies that seem unusual. These galaxies, surprisingly big given their young age, defy our usual cosmic expectations. Based on our common understanding, smaller galaxies should form first and then increase in size over time. However, these faraway giants suggest a different story. Imagine if these massive entities weren't regular stars but dark stars, wrapped in mystery, perhaps holding the key to their rapid growth. Driven by the enigmatic actions of dark matter, these dark stars could quickly grow to enormous sizes. This complex dance, a blend of dark matter and energy, could clarify why there were so many massive galaxies in the early universe. As we look even deeper, we come across extraordinary cosmic wonders called Mothra and Godzilla, stars that go beyond our predictions. These kaiju stars, incredibly luminous, are located over 10 billion light-years away. Mothra, a double supergiant, creates a cosmic show where one supergiant glows like 50,000 suns, while its companion shines with a brilliance 125,000 times that of our sun. In the immense collection of stars, Godzilla stands out as the brightest ever found. Yet, a mystery emerges as its brightness surpasses what can be clarified by the gravitational lensing of a distant galaxy cluster. Something elusive hides in the shadows. Driven by curiosity, scientists calculate its mass to be an astonishing 10,000 to 2,500,000 times that of our trusty sun. Now, here's the intriguing part. Whatever escapes the detection of the James Webb Space Telescope isn't an ordinary star or a cluster of stars. It lingers unseen, a ghost in the vastness, possibly a black hole or a densely packed mass of dark matter. The structure of space itself suggests hidden realms, maybe a tiny galaxy made mostly of this mysterious dark matter, strengthening its puzzling presence. These findings are fascinating, painting a picture of a universe more intricate and perplexing than we previously imagined. The James Webb Space Telescope is leading us through this cosmic puzzle, and with every revelation, the mysteries become even more profound. The presence of dark stars not only makes us rethink our ideas about the universe, but also hints at the existence of dark matter particles involved in mysterious activities, well beyond the reach of gravity. The formation of galaxies. The way galaxies form is pretty complicated and takes billions of years. Scientists usually explain it using the hierarchical model, which says galaxies grow by smaller structures, merging due to gravity. This cosmic story began with cosmic inflation, a quick expansion right after the Big Bang, setting up the big-scale structure of the cosmos. As time passed, dark matter, this unseen and mysterious stuff, played a huge role in shaping the cosmic web. Dark matter started coming together because of gravity, making big halos. These halos acted like a gravitational frame for visible matter to gather. Within these dark matter halos, clouds of gas and dust began getting denser. These clouds collapsed under their gravity, starting the formation of structures that would later become galaxies. Next up in this cosmic tale is star formation. The collapsed clouds split into smaller regions where stars were born. The first stars, called population 3 stars, were mainly made of hydrogen and helium. These stars were crucial in filling the space between stars with heavier elements through nuclear fusion and supernova explosions. Galaxies kept changing through mergers. Smaller galaxies came together due to gravity, forming larger and more massive galaxies. This galactic merging is still happening, and some galaxies, like our Milky Way, are still interacting with smaller ones. Galaxies come in all sorts of shapes like spirals, ellipticals, and irregular forms. These shapes are influenced by things like the amount of gas, how fast stars form, and the history of mergers. Over time, galaxies keep evolving through processes like star formation, supernova explosions, and the effects of supermassive black holes at their centers. A journey through time. As we admire the amazing discoveries made by the James Webb Space Telescope, let's look back at how our ideas about space have changed over the years. Not too long ago, earlier telescopes like the Hubble showed us glimpses of space's vastness. Back then, people believed that galaxies formed in a certain way, small ones first, growing bigger with time. This idea came from thinking that the universe's growth resembled how living things grow. But the discoveries from the James Webb Space Telescope challenge this old idea. The telescope finds galaxies like Mothra and Godzilla, which, despite being young, don't fit the expected story. This makes us rethink what we thought we knew about how celestial bodies develop. Now, let's go back to when dark matter and dark energy were new concepts. Early astronomers, using basic telescopes, could only see the stuff they could see with their eyes. They didn't know about an invisible force, dark matter, quietly controlling how galaxies move. The term dark universe, which we use a lot now, shows how our understanding has changed. Recognizing that darkness, once seen as emptiness, is a big force influencing most of our cosmos. Scientists like Paul M. Sutter say the universe is mostly dark, marking a change from what we used to think. Talking about dark stars challenges the old idea of how stars are born. Before, we thought stars formed by putting hydrogen together to make helium, like our sun. Now, dark stars, powered by dark matter, show us another way stars might come to be, going beyond the usual nuclear fusion. As we get excited about these discoveries, it's important to see how our ideas about space keep changing. Each telescope, from Hubble to the James Webb Space Telescope, has been like a light helping us explore new parts of the universe. The universe, once a big mystery, is now showing us its complexity and surprising us. In this journey through time and space, the James Webb Space Telescope keeps teaching us a ton about space. Every time it looks at something new, it has the power to change what we know about the universe and make discoveries. It's like a space superhero helping us understand the secrets of the cosmos. Are we ready for contact with extraterrestrial beings? Share your thoughts in the comments. Also, share, and subscribe for more interesting content.